Welcome back. In this video, we are going to explore how measuring circles helps us discover one of the most important numbers in mathematics, pi. We'll begin with 5 circles, and we want to start by measuring their diameters. So as a reminder, a diameter is the longest line segment through the center. So it is a line segment through the center, and both of the endpoints need to be touching the circle. So for instance, for the smallest one, this right here would be my diameter. Let's say the diameter, so I'll denote this by D. For the first one is 1 centimeter. The second one is 2 centimeters. The third one is 3 centimeters. The fourth one is 4 centimeters. And the fifth one is 5 centimeters. It's helpful to have students actually have some circles where they can actually measure these diameters with rulers or other tools. The next step, we want to measure the circumference, the distance around the edge. That's a little bit trickier. We can do this with flexible tape measures, or we can use string that we wrap around, mark, and then measure it with a ruler. But let's suppose we do want to measure each of the circumferences of these circles. When we do, our first one is 3.1 centimeters. The second one is 6.3 centimeters. The third one is 9.4 centimeters. Our fourth one is 12.6 centimeters. And then finally, our fifth one is 15.7 centimeters. Now we're going to divide. We're going to divide circumference divided by diameter for each of these. For our first circle, 3.1 divided by 1 is 3.1. For our second one, 6.3 divided by 2 is 3.15. Our third one, 9.4 divided by 3 is approximately 3.13. 12.6 divided by 4 is approximately 3.15. And then 15.7 divided by 5 is 3.14. And all 5 of these numbers are approximations of pi. This is a wonderful mathematical discovery. No matter which circle we measured, the ratio of circumference to diameter stayed very close to that same number. That number is pi. In fact, we can say that the circumference divided by the diameter is in fact pi. If we multiply both sides of this equation by d, we end up with that c is equal to pi times the diameter. Or, since the diameter is 2 times the radius, 2 pi r, our formula for circumference. Now, let's ask an important question. Why didn't we get an exact value for pi from our measurements? The answer is measurement inaccuracies. In real life, measurements are only approximate. Maybe the ruler is not perfectly aligned. Maybe the circumference is hard to measure exactly. Maybe the drawing is not perfectly precise. Maybe the numbers were rounded. So our results are close to pi, but not exact. That's a very important teaching point. Pi is not exactly 3.14. That is only an approximation. Pi is an irrational number, which means its decimal goes on forever without repeating. As future teachers, this is a good place to emphasize the difference between an exact mathematical relationship and a measured approximation. Students often first encounter pi as just a button on a calculator or a number to memorize. But this activity shows where it comes from. It comes from comparing circumference and diameter in circles of different sizes. That is powerful. A helpful classroom question here is, what stayed the same even though the circles got bigger? The answer is the ratio of circumference to diameter. Great work. This is a beautiful example of a formula growing out of measurement and pattern. In the next video, we'll use a visual rearrangement argument to understand the area of a circle.